In this function, we are going to look at graphing sinusoidal functions. First, we will look at graphing the sine function, and then we will look at graphing the cosine function. To do this, we are going to revisit the unit circle that we saw in the previous units, and we're going to use the ratios at every 90 degrees to find key points on the graph. So in graphing the sine function, we are graphing the ratio versus the angle. So the independent variable, the x-axis, is theta, the angle, and the y-axis, the dependent variable, is sine theta, which is the ratio, and the ratio depends on the angle. So now let's look at the unit circle, and we're going to start at 0 degrees. Remember, we look at the y values when finding the sine ratio. So at 0 degrees, the value of sine of 0 is 0. So we're going to plot that. Here at 0 degrees, we're going to go up 0. So then as we go from 0 degrees and we increase the degree up to 90 degrees, we see that the y value is getting higher and higher and higher until we reach that value of 1. So at 90 degrees, we have a y value of 1. So we have to find 90 degrees on our scale. So 1, 2, 3, 4, 5, 6 intervals is 180. So that means 3 intervals would be 90 degrees. And at 90 degrees, the ratio is 1. So I will draw that point there because 2 intervals has that value of 1. And so now that we're at 90 degrees, we're going to increase the angle and go up to 180 degrees, but now the y value starts coming down. So we're going to go back down to that y value of 0. So at 180 degrees, here the y value, the ratio, is again 0. And now as we go past 180 degrees to 270 degrees, so bigger angle, we now have negative y values. So at 270 degrees, we have that y value of negative 1. So now at 270 degrees, which I have to find, so I know every 3 intervals is 90 degrees, so 3 more is 180, so 3 more would be 270. So 270 is here. I now have a value of negative 1, so I'm below the x-axis. And then we keep going around, increase that angle. We're still negative, but we are becoming less negative, and we actually go back and reach that y value of 0. So again, we at 360, we are now at a ratio of 0. We have completed one full rotation around the unit circle. So now I'm going to connect these points to show that on the sine graph. And it's curved at the top. So you start at the origin, you come up, you curve in, so it's not a V, and then you curve back down, go through the x-intercept to that minimum point at -1, and then curve back up. So that is one cycle of the sine curve. If you notice, there are 5 points that we plotted to get this one cycle, and you do need to show all 5 of those points. But we can actually continue this curve by keep going around the unit circle. So we finished at 360 degrees. So if we were to go another 90 degrees, that would be 450 degrees. So another 90 degrees on my x-axis here would be 3 more intervals, so that's 450, and that is at the same ratio as 90 degrees, so that has a ratio of 1. Remember, we can say that 450 degrees is coterminal to 90 degrees, and they have the same ratio. So at 450, we're going to plot that point at 1, and then we will keep going around the unit circle, 90 degrees more. So 450 plus 90 degrees is 540 degrees. So at 540 degrees, the y value is 0 because it's coterminal to 180. So we're back at the x-axis. And then go another 90 degrees. We are now at 630 degrees where the y value is -1. So at 630, we have that y value of -1. And then if you keep going back to the starting point, another 90 degrees, we will now say that this is 720 degrees because we have gone around the unit circle twice. So we are back at a ratio of 0. So now we can draw more on our sine curve, and we left off at 360. So from there, we're going to go up to that ratio of 1 at 450 degrees, and then at 540 we're back down to that ratio of 0, and then at 630 that ratio of -1, and then at 720 that ratio of 0. So we now have drawn 2 complete cycles of the sine curve. What you should notice is that the second cycle is identical to the first cycle. So the first cycle starts at the origin, which is on the midline. The midline cuts the curve in half. So we start at the midline, 90 degrees later, we're at a maximum. 90 degrees later, we're at the midline. 90 degrees later, we're at a minimum. 90 degrees later, you're back at the midline. And that's one complete cycle. Then the next cycle, we start at the midline again, just like we did for the first cycle, up to a maximum at 90 degrees later. 90 degrees later, we're back to the midline. 90 degrees more, we're at the minimum. 90 degrees more, we're back to that midline. So you can see that the first and second cycles are identical, and we have the 5 key points to show the shape of that curve. There are many other ratios in between those 90 degrees that we've plotted, but we just need these 5 points for one cycle to capture the shape of that curve. If you were asked to keep graphing after 720 degrees, you could keep using your unit circle, or you can just look at this pattern and know that after 720 degrees, at 90 degrees more, you're going to be at a maximum. 90 degrees after that, you're going to be back to your midline. So you're using this pattern that you can see from the first and the second cycle. And you can do that on the left side over here. So there's room on this grid, so we may as well graph on the left. So here we're at the origin. So if we're going to go 90 degrees to the left this time, so at -90 degrees, just using this pattern, you see that you're going to be at a minimum. So you're going to be at -1. And if you were to look at the unit circle, -90 degrees means we go clockwise. So you are here at -90 degrees, where the ratio is -1. So we see that. And then -80, you keep going clockwise, 180, and you have a y value of 0. And then looking at the pattern here, that makes sense because we're at a minimum, so we have to go back up to that midline where the y value is 0. And then again, we can use the pattern. We're at minimum, back to midline, so now we have to go to the maximum. So at -270 degrees, we know that we should have a maximum of 1. And again, you can check that on your unit circle. -270 degrees is where the y value is 1, so that looks right. And then at -360, we're going clockwise 1 full rotation. So again, we're back to that y value of 0, and that makes sense because we're at a maximum, so we have to come back down to our midline, which has a ratio of 0. So to continue that, again, this part of the curve looks identical to the other 2 cycles. So we now have 3 cycles of that sine curve. And now that we have our curve, we should just label it. So y equals sine theta. Sometimes you'll see that as y equals sine x. Let's just talk about some of the key features that we see from this graph. The period is how long one cycle takes. So let's look at the first cycle that we drew, the one in pink. We started at 0 degrees and we ended at 360 degrees because that's when it starts to repeat. So the period is 360 degrees. So that means all of your cycles should have 360. So the next one in purple, we start at 360, we end at 720, so that took another 360 degrees. And the one in green, we start at -360 and we ended at 0. So again, that took 360 degrees. The midline is the line that cuts the curve in half. So here the midline is the x-axis, which has the equation y equals 0. the maximum value, so the maximum ratio that a sine curve can have is 1, and the minimum value can have is -1. So we know that from the unit circle, but also you can see the maximum and the minimums. And the amplitude is the distance away that the minimum is from the midline and the maximum is from the midline, and that should always be the same. So here we see the maximum is 1 unit away from the midline and the minimum is 1 unit away from the midline. So the amplitude of this sine curve is 1. The x-intercepts, there are many. So we can't possibly list them all because this curve actually continues past these 3 cycles. So what we say is we take the first one, which is at 0 degrees. So we say 0 degrees. And then we see that the next one occurs at 180, 360, 540, 720. So basically every 180 degrees added or subtracted. So we say plus 180 degrees n. And then we say n is an element of integers. So this is mathematical notation, and it basically just says that an x-intercept occurs every 180 degrees, starting at 0 degrees. So n is an element of integers, so it can be positive or negative numbers, and n can also be 0. So when n is 0, 180 times 0 is 0, so our first one is 0. When n is 1, you get 0 plus 180, so 180 degrees. When n is 2, you get 0 plus 180 times 2, which is 360 degrees. When n is -1, you get 0 plus 180 times -1, which is -180 degrees. So this is just a way of talking about all of the x-intercepts. The y-intercepts, well, there's only one. The y-intercept, it crosses the y-axis at 0. And then the domain, well, look to the left and the right to see if there's any restrictions. That curve can just keep going. We just drew 3 cycles, but it could keep going. So here, instead of using x, we're going to say theta is an element of all real numbers. But then when you look at the range is restricted. The maximum, the sine curve can be as 1, and the minimum is -1. So the curve only exists between -1 and 1. So we're going to say y is an element of all real numbers such that y is greater than or equal to -1, but less than or equal to 1. So this is a double inequality. The y is in the middle of these two y values. So we start with the smallest value, and then we do less than or equal to y, less than or equal to 1. So we are now going to look at the cosine function. So again, we're going to use the unit circle, but this time looking at the x values of the coordinates to find the cosine ratio. We are going to plot the cosine ratio on the y-axis because we're plotting the ratio versus the angle. So first, when the angle is 0 degrees, the coordinate is 1, 0, so the ratio is 0. So that means the cosine function does not start at the origin. We actually start at this maximum value of 1. And then as we go from 0 to 90 degrees, the x values become smaller until they reach the x value of 0 at 90 degrees. So that means cos of 90 is 0. So then I'll plot that point at 0. And then as we increase from 90 to 180 degrees, the x values become negative until they reach -1. So at cos of 180 degrees, we have a ratio of -1. And then at 270, we have a cosine ratio of 0. And then back here around one full rotation around the unit circle at 360, the x value is 1. So we have gone around one full rotation around the unit circle, which means we have drawn one full cycle of that cosine function. We have started at a maximum, we went down to the midline, went to the minimum, back to the midline, and back up to the maximum. And again, every 90 degrees, something is happening. So we are going to graph this, connect these points together just like we did for the sine function. You curve when you hit a minimum or a maximum, and then you cut back up to the midline and then curve again at that maximum. So it's not a V at the maximums and the minimums. So now let's use the 5 coordinates that we've already plotted in our first cycle to draw the next cycle in the cosine function. So we left off at a maximum. So in the first cycle after the maximum, 90 degrees later, we were on the midline. So 90 degrees after this maximum, we're going to be on that midline at 450 degrees. So we're on the midline. So at 90 degrees, we were on the midline. 90 degrees later at 180, we are at a minimum. So right now we're at 450 on the midline. 90 degrees later, we should be at that minimum again. So at 540 degrees, we are at -1. And then from there, we went back up to the midline. So again, 90 degrees after this, I'm going to go back up to that midline. So at 630 degrees, I have a ratio of 0. And then 90 degrees after that, I'm back up to that maximum. So at 720, I'm going to be back up that maximum. So I've just plotted the 5 points of the second cycle. And I just used the first cycle to help me find those points. But again, you could keep using that unit circle and see where you are every 90 degrees. So now I'm going to continue that curve to show that second cycle. And then again, we can do the same thing for the negative angles. So at that maximum, I can't go any higher, so I have to go back down. So at 90 degrees, before I get to the minimum, I have to stop at that midline. So I know that there's going to be a point here at that midline. And then 90 degrees later, so at -180, now that I'm at that midline, I got to keep going down till I get to that minimum at -1. 90 degrees later, I can't go any more negative. I stop at -1, so I gotta go back up. But before I go to the maximum, again, I gotta stop off at that midline. So I'm gonna draw a point. That's -270 and 0. And then again, 90 degrees later, I'm back up at that maximum. So again, I've drawn 3 cycles from a maximum down to a minimum, back up to a maximum for the first cycle. The second cycle, again, started at a maximum, down to the minimum, back up to a maximum. And then that third cycle, which is at the beginning, but I drew last, I'm at a maximum, down to a minimum, back up to a maximum. So I have 3 complete cycles. And so now I'm just going to label the equation y equals cos theta. And now let's talk about the different properties from this graph. So the period, again, is how long it takes for one cycle. So at 0 degrees, we're at a maximum. The next time we're at a maximum is at 360 degrees. So that period is 360 degrees. The midline cuts the curve in half. So again, that's the x-axis. So that has the equation y equals 0. The maximum we see is 1, the minimum is -1, and the amplitude is the distance from the maximum to the midline. So the curve is 1 above the midline and 1 below the midline. The x-intercepts, last time on the sine curve, the first one was at 0 degrees. Here the first one is at 90 degrees. So I'm going to start off with 90 degrees. And then it's every 180 degrees later we have an x-intercept. So just like before, we're going to say plus or minus 180n, where n is an element of integer numbers, meaning that there's multiple x-intercepts. The y-intercept, so looking at the y-axis, there's only one, and this time it's at 1. So the coordinates are 0, 1. The domain, there's no restriction in the domain, so theta is an element of all real numbers. And the range, again, if you look at those y values, they are between -1 and +1. So y, this is a double inequality. Y is greater than or equal to -1, but less than or equal to 1. So now let's just quickly discuss the similarities and differences between these two functions. As you can see, they look very similar. In fact, you might even notice that the cosine function is just a transformation of the sine function. It's just been shifted 90 degrees to the left, or you could say it's been shifted 270 degrees to the right. And we do actually call both sine and cosine functions sinusoidal functions. So there are quite a few similarities that we are going to list. Let's first look at the period. So for a sine function, the first cycle, we're going to say starts at 0 degrees and it ends at 360 degrees. So the period is 360 degrees. For the cosine function, again, start at 0 and end at 360 degrees. So both have the same period. They also both have the same midline. That line cuts through at the x-axis, cuts the curve in the middle. They both have the same maximum value. They occur at different x values at different angles, but they both have a maximum value of 1, and they both have a minimum value of 1. And they also both have the same amplitude because they're one above and one below the midline. And they both have the same domain and range. Domain is not restricted, and a range is in between the minimum of -1 and the maximum of 1. So I've listed the similarities there. And then for the differences, let's look at the intercepts. So for the sine curve, the first x-intercept is at 0, and then it occurs every 180 degrees. But for the cosine function, the first x-intercept is 90, and then it occurs every 180 degrees. So the x-intercepts are different. Also, the two y-intercepts, sorry, the one y-intercept, each has a one y-intercept. For the sine curve, it's 0, and for the cosine curve, it's 1. And something else that I have mentioned, and it becomes more important later in this unit, is where the sine and cosine curves start. So at 0 degrees, this sine curve starts at the midline, and then it goes up, and this cycle ends at the midline. The cosine curve at 0 degrees starts at a maximum, and then it goes down to the minimum and back up to a maximum. So we will recognize cosine curves from starting at maximums or minimums, actually, if there's a reflection, and cosine curves starting at midlines. We are going to be moving into the transformations of both the sine and the cosine functions. So make sure you know what the base graphs look like. Remember that you need to plot 5 points when you're creating one cycle of the curve.